Hello class, this is Ms. Riggins, and today we're going to be talking about area. Now I know that in class we've been talking about area and refreshing your memories from middle school, but today we're going to be talking about a way to calculate the area of a shape that you did not learn on how to calculate the area of in middle school, and that is the shape of a regular polygon. And if you don't remember what a regular polygon is, a regular polygon is a polygon that is equilateral, which means all the sides are congruent, and equiangular, which means all the angles are congruent. As you can see here, in this particular polygon, all the side lengths are congruent and all the angles are congruent. And even as I change the length of the sides, that still remains. So in this case, we have a regular polygon. And one of the things that a regular polygon has, every regular polygon has a circumscribed circle, which means there is a circle that can be drawn so that all the vertices of a polygon lie on that circle. So an example of the circumscribed circle for this particular polygon is this circle. As you can see here, all the vertices of the polygon lie on the circle. So we call this a circumscribed circle, and that the polygon is inscribed in the circle. And every circumscribed circle, well, every circle has a radius and a center. And if you want to take a look at the center, here's the center of the circle. And by definition, a radius is a line segment that starts from the center of a circle and goes to the end of a circle. So I can easily make a center of the radius of the circle by just connecting these 2 points. And so here we have a radius of the circle that is found by the center of the circle. Okay? So this is not new, it's just that you guys are new to using center and radius with a polygon. You're used to using it just with a circle. And of course, a polygon doesn't have a center or radius unless it can be inscribed on a circle. So how is that important, and how can we use that to find the area of a polygon, a regular polygon? Well, as you can see here, if I were to connect radius from each vertex of the polygon to the center, I would break the polygon up into a certain shape that you do know how to find the area of. And as you can see here, these shapes are called central triangles because they are formed by the central angles of a polygon. So as you can see here, that this polygon has 5 central angles, and a central angle again is an angle formed by 2 radii of the polygon, which means the vertex of each of the central angles is the center of the circle. And what do you notice about these central angles in relationship to one another? If you said that you notice that those central angles are congruent, you're absolutely correct. Those central angles are congruent. So what does that mean for us? So that it won't get so busy, I'm only going to just show you 2 measures of the central angles, and as you can see, they are congruent. Well, what kind of triangles are produced when we use this method to break up the regular polygons? Well, if you said that the triangles are isosceles, you're absolutely correct. And we know they're isosceles because they have 2 side lengths that are exact same, because both side lengths are again radii of the circle. So we have 2. So what does this have to do with what we're trying to find, which is the area of the polygon? Well, I can find the area of the polygon by basically finding the area of all of the triangles. And since all the triangles are congruent, then all I have to do is to find the area of one of the triangles and multiply it times the number of triangles, and therefore that will be the area of the polygon. So let's take a look. If you recall, the area of a triangle is 1/2 base times height. So the base, we learned last class that the base can be any side of the triangle, but for the purposes of this lesson, we're going to use the base that represents the horizontal side length, or the non-isosceles side of the triangle, and that's the base of this polygon. And since all the since all the sides of the polygon have the same length, then that means we can change this formula to area is 1/2 s times h, where s is the side length of the regular polygon. So in this case, it's 4.88. And then we have the height of the regular polygon, but we don't want to confuse it with the actual height of the polygon, because distance from the vertex to the opposite side is the height of the polygon. We don't want to confuse that with the height of the triangle. So we're going to call the height of the triangle a special name, and that's going to be the name called the apothem. I know you guys are like, apothem, but it's a way to differentiate between the height of the actual polygon and then the height of a central triangle. So in order to find the area of this polygon, we would have to use, we would take 5 and multiply it times the area of one of the triangles. And that area of the triangle can be found by 1/2 times S times A. Well, we're going to have another way to express that in the notes. But when we do that, we'll have the area of the entire polygon. So let's take a look at our notes. On page 135, we have the notes of a regular polygon. And again, the center is the center of the polygon is the center of the circumscribed circle. The radius of the polygon is the radius of a circumscribed circle. The apothem of a polygon is the distance from the center to any side of the polygon. And that's what we're going to be using as the height of the central triangle. And the central angle of a regular polygon is formed by 2 radii drawn to consecutive vertices of the polygon, which is what we've already talked about in the first few minutes of the video. So now let's take a look at how to find the area. As you can see, you can find the area of any regular polygon, n-gon, with a side length of S by basically multiplying 1/2 times the apothem times the side length times the number of sides. So this basically rearranged what we already did. We use, in our particular example, we use 1/2 the base, which we said was S, the side length of the polygon, and A to represent the height, and we multiplied it times N, which is the number of triangles. And in this case, the number of triangles in this regular polygon is 6, but in the previous example, we had 5. Well, another way to describe N times S, well, since each regular polygon has congruent sides, if I take the side length and multiply it times the number of sides, another way to represent N times S is by the perimeter of the polygon. So we can rearrange that to look something like 1/2 A times P, where P represents the perimeter of the polygon. But either which way is fine with us. So in order to find the area of the polygon, what we're going to be working on in the next few days is we're going to be working on how to find those 3 things. The number of sides of the polygon, the side length of the polygon, and the apothem of the polygon. And as you can see, if you notice that the polygon, the central triangle, it can be broken up into several right triangles. And as you can see here, here's a right triangle where the base of the polygon is 1/2 of the side length, and the height of the polygon is A. So to figure out the radius, we can use Pythagorean theorem in that way if we know 2 of the sides. And then we have other methods that we're going to work on in class today, and next class, and well, basically this week. So that's about it. We look forward to working on it in class. Make sure you print out the notes. They will be very helpful.